The sun, our life-giving star, is both a symbol of warmth and a force of unimaginable power. It's a nuclear powerhouse, constantly churning with energy, and at times capable of unleashing chaos on a cosmic scale. Today, September 7, 2025, NASA and global space agencies have issued a dire warning. A massive solar storm is racing toward Earth, faster and more intense than most have ever witnessed. This G4 class geomagnetic storm, just shy of the most extreme level, threatens our technology-dependent civilization, putting everything from power grids to satellites at risk. Its source? A volatile sunspot, Arkansas 3882, which erupted with a colossal X-class solar flare and hurled a coronal mass ejection, CME, directly at us, sending a wave of charged particles on a collision course with our planet. The CME is traveling at over 3 million miles per hour, giving us only hours to prepare for its impact, barely enough time to brace for what's coming. Governments and emergency services are scrambling, activating emergency protocols and warning the public, knowing the question isn't if the storm will hit, but how hard and how widespread the effects will be. We're at the peak of solar cycle 25, a period marked by intense solar activity and escalating risks, with scientists predicting more frequent and severe storms in the coming months. Just last year, a G5 storm caused GPS disruptions, affecting flights, shipping, and emergency services worldwide, and hundreds of millions in damages, a mere preview of what's coming if this storm strikes with full force. This time, the threat is amplified by the storm's unique composition, its direct trajectory, and the sheer speed at which it approaches. Our global resilience is about to be tested like never before, as humanity faces one of the most formidable challenges from the cosmos in modern history. To truly grasp the danger we face, we must first understand the anatomy of the storm itself, how it forms, evolves, and ultimately threatens our world. This isn't a typical CME, it's what scientists call a cannibal CME. This rare phenomenon occurs when a faster, more powerful eruption from the sun overtakes and merges with a slower-moving one ahead of it, combining their energies into a single, supercharged plasma cloud. The result is a storm far more intense than either eruption alone could produce. The outcome? A massive, turbulent, and magnetically complex projectile, confirmed by NASA's SOHO satellite to be on a direct collision course with Earth. This is not just a routine solar event, it's a cosmic bullet aimed at our planet. At the heart of this event is Sunspot AR 3882, a colossal region on the sun's surface many times larger than Earth itself. This sunspot acts as the launch pad for the XClassFlare that set everything in motion. The energy released in this eruption is almost unimaginable, equivalent to the detonation of billions of hydrogen bombs, blasting a billion-ton chunk of the sun's atmosphere out into the solar system at incredible speeds. As this immense cloud of plasma races through space, it drags the sun's magnetic field along with it, twisting and distorting the field lines as it goes. When this superstorm collides with Earth's magnetic field, the orientation of the two fields, whether they align or oppose each other, will determine just how severe the impact will be. If the CME's magnetic field is oriented southward, it effectively unlocks a gateway, allowing a torrent of solar particles to pour directly into our atmosphere, fueling dramatic auroras and geomagnetic disturbances. All signs point to this cannibal CME having the perfect combination of speed, energy, and magnetic orientation to trigger a severe geomagnetic storm, one that could disrupt technology on a global scale. The speed and energy involved are staggering. This plasma cloud will cover the 93 million miles from the sun to Earth in just over a day, moving at millions of miles per hour. Imagine a hurricane, but instead of wind and rain, it's a relentless storm of charged particles and magnetic forces, swirling invisibly around our planet. The stage is set for widespread disruption. Power grids, satellites, and communication networks all stand vulnerable to the storm's fury. The shot has already been fired, and now all we can do is brace for impact. Earth's magnetosphere is our invisible shield, deflecting the relentless solar wind and protecting all life from harmful radiation that constantly bombards our planet. But a CME of this magnitude compresses the magnetosphere, pushing its boundary dangerously close to the surface, threatening our safety. Satellites in orbit are suddenly exposed to intense radiation, risking immediate and potentially catastrophic damage. The CME's magnetic field can link with Earth's, funneling torrents of high-energy particles into our upper atmosphere. This supercharges the auroras, but also signals that our protective shield is being breached. The upper atmosphere heats and expands, increasing drag on satellites and threatening their orbits with decay. More critically, geomagnetic activity induces powerful electrical currents, GICs, flowing through the ground and infrastructure. These invisible currents are the direct threat to our infrastructure, putting our technology at risk. The real danger is about to begin and the world holds its breath. Geomagnetically induced currents, or GICs, are the storm's most dangerous weapon. These invisible surges of energy, unleashed by solar storms, can travel for hundreds of miles through the very wires that power our civilization. They surge through power lines and pipelines, turning grids into giant antennas for unwanted energy. The result is a silent, relentless assault on the backbone of our infrastructure. Transformers can overheat and fail, triggering cascading blackouts across entire regions. One failure can quickly multiply, spreading darkness from city to city in a matter of minutes. A prolonged outage would cripple hospitals, water treatment, finance, transportation, and food supply chains. Everyday life would grind to a halt, and essential services would be pushed to the brink. Our dependence on electricity and data makes us uniquely vulnerable. The more advanced our society becomes, the more exposed we are to these invisible threats. Satellites face their own peril. Solar particles can fry electronics, disrupt GPS, and distort radio signals. Even a brief disruption can have global consequences, affecting everything from navigation to weather forecasting. GPS failures would paralyze shipping, aviation, and even the timing of financial markets. The ripple effects would be felt in every corner of the globe, halting the flow of goods and information. Our interconnected world, usually a strength, becomes a weakness as failures cascade from one system to another. What starts as a technical glitch can quickly become a full-blown crisis. A power grid collapse takes down communications, GPS loss cripples logistics and emergency response. In a matter of hours, chaos could replace order, the economy could grind to a halt, factories would stand silent, and financial transactions would freeze, threatening livelihoods everywhere. We've built a global house of cards, and a solar superstorm could bring it all down. The systems we trust every day are more fragile than we realize. The threat is not just theoretical, it's imminent. Scientists warn that it's only a matter of time before the next big solar event tests our resilience. The fragility of our digital society is about to be exposed. Are we ready to face the storm, or will we be caught off guard when the lights go out? To understand what's at stake, look back to 1859, the Carrington Event, the most powerful geomagnetic storm ever recorded. Auroras lit up skies as far south as the Caribbean, and telegraph systems sparked and caught fire. Back then, technology was limited. Today, our dependence is total. A Carrington-class event now would destroy hundreds of transformers, crippling power grids for months or years. Recovery could take a decade, with costs in the trillions. This isn't just about lights going out, it's about the collapse of essential services. The G4 storm may not match 1859's intensity, but it's a stark reminder of the sun's power. Our civilization is far more exposed than we realize. The sun holds a loaded gun to our way of life. This week's events prove the trigger can be pulled at any time. Our best defense is prediction, and recent advances have given us new tools. NASA and IBM's AI model, Surya, can now forecast major solar flares with unprecedented accuracy, giving us precious extra hours to prepare. But even with AI, warning times are measured in hours, not days. This limited window forces a frantic race to protect power grids and satellites. Operators scramble to reroute power, take transformers offline, and put satellites in safe mode. These are vital but reactive measures. Recent emergency drills reveal troubling gaps in our readiness, especially in public communication and infrastructure coordination. How do you warn millions without causing panic? How do you protect food, water, and healthcare? The truth? We're still dangerously unprepared for a crisis of this scale. Prediction buys us time, but not enough. Whether this storm is a near miss or a direct hit, it's a wake-up call for humanity. Space weather is not just an astronomer's concern, it's a global security threat. The auroras lighting up the skies are a beautiful warning of the power unleashed on our planet. Experts urge immediate action, harden our electrical grid, and invest in technologies to block geomagnetic currents, build reserves of spare transformers and fortify critical infrastructure, advance solar storm prediction with more observatories and better models. A satellite at the L5 Lagrange point could give us days of warning, not hours. We must recognize our vulnerability in the cosmic shooting gallery. The sun's message is clear. Understand, prepare, and respect the forces at play. Let's hope we have the wisdom to listen.